everyone, we are Group 32 and our project is called Gamifying EDA. Our project explores will make a game successful on the Steam platform. Specifically, we're testing whether a game's genre and categories is a strong predictor of success, measured by metrics like average time, concurrent users, and Metacritic scores compared to other game features. Our group members are Selena, Jaden, Nat, Iran, and Lee. We are using the Steam Games dataset from Kaggle, which includes over 100,000 observations and 39 features like release dates, developer, estimated copy sold, and genre. After loading and inspecting the dataset, we cleaned it by removing missing values and standardizing some columns for analysis. In terms of the research background, the video game industry is a massive global market, and understanding the elements that lead to the game success is important for stakeholders like developer and marketers. Previous studies have found ideas such as multi-platform releases help games reach more players, which leads to a greater engagement and better ratings. Accessibility features like language localization make games more visible and appealing to international users, especially in markets with large language groups. In terms of our research question and hypothesis, our null hypothesis states that after encoding genre category as a binary indicator variables with one-hot encoding, the average strength of the correlation between genres and success metrics is not significantly different than the average strength of the correlation between categories and the success metrics. And next, we will move on to the exploratory data analysis part to test our hypothesis and uncover patterns.
For the EDA section, we started by doing some univariate analysis by making histograms for the 5 success metrics. Immediately, you can see that most of them are heavily right skewed. In other words, a lot of games have really low engagement, and it's just a few of them that have good performances. This suggests that we might need to do some transformation before conducting our tests. Next, we conducted some bivariate analysis with a correlation heat map. We noticed that the pairs with the highest 2 correlations both involves peak CCU as one of the elements. This indicates that optimizing peak CCU might be a good idea for a prediction model. We also did more graphs for the one-hot encoded values of categories and genres. For both category and genre, we made a simple bar graph showcasing the count of games in each category and genre. Next, we made a mean z-score heat map between categories and success metrics, and the same heat map for genres and success metrics. By observing these heat maps, we can see that which categories and genres contains the best average z-scores for each success metrics. For the testing section, we first log scaled each of these success metrics to deal with the skewness we discovered in the EDA section. Then we split the one-hot encoded columns into category columns and genre columns. Then we fit a linear regression model and a random forest model for each pairing of categories to success metrics and genre to success metrics. A random forest model is used on top of a linear model here because a random forest model is less sensitive to skewed data. Then we computed a R-squared value for each of the models we trained, and we separated the R-squared values to the ones related to categories and the ones related to genre. Finally, we conducted a pair t-test on these R-squared values and found that the average strength of correlation between genre and success metrics is significantly different from the average strength of correlation between categories and the success metrics.
And next, we conducted an ethics review to ensure our analysis was both responsible and respectful. Ethical considerations are especially important when using real-world data, even if it's publicly available, because the way we interpret and present findings can still reinforce existing biases or exclude underrepresented groups. By conducting this review early on, we aim to make our work more transparent, inclusive, and trustworthy. Our dataset comes from Kaggle and was ethically sourced under Steam's terms of services. It contains no personal identifiers, and we're not collecting any new user data, so privacy concerns are minimal. That said, we do recognize some potential biases. One key issue is geographic bias. Steam's user base is heavily centered in North America and Europe, which may affect how the data is represented in our analysis. And to address this, we'll group by language or region when possible and avoid assumptions about age, gender, or location. Moving on to discussion and conclusion, we found that no single feature predicts a game's success. Genre alone wasn't very helpful, but categories like multiplayer or controller support made a bigger difference. Our models confirmed this, with category-based features consistently outperforming genre and predicting popularity. This shows that game success is complex and shaped by many factors. While our project had limits, like only using Steam data, it gave us real insight into what engages players, and showed how data science can help explain success in creative industries, like the gaming one. And moving on to team contributions, these are our team contributions. Everyone called for everything for each of the checkpoints and contributed fairly to the overall project. Thank you for listening.